Whatever content I'm going to cover is, first I'll give a brief introduction of why do we require the radiation quantities and the units. Then I'll go to activity, what is activity, then kerma, exposure, absorbed dose, equivalent dose, effective dose, collective effective dose, which is usually ignored because of the lack of importance in exams as well as during the interviews. And finally, the summary. Introduction. What is a quantity? A quantity means any physical phenomenon requires something to characterize in terms which is suitable in numerical expressions. If there were no quantity, we could not measure anything. A physical quantity is a phenomenon capable of expression as a product of number, and it has a unit. What is a unit? It is a selected reference sample of a quantity. Usually, we collect a sample and we design a unit to measure the quantity. Like, okay, for unit of light, we have lux, Lux, lux. For unit of length, we have multiple like centimeters, meters, inches, foot, and kilometers. Radiation units and quantities cannot simply be determined by anyone, but they are ruled by governing bodies. The governing bodies are ICRP, or International Commission on Radiation Protection, ICRU, which works very close with the ICRP. The full form is International Commission on Radiation Units. ICRP is a private members from different countries throughout the world. The aim of ICRP and ICRU is to prevent the deterministic effect and reduce the risk of shocks and what are however low the dose be. ICRU was found in 1925 and it comprises 19 committees. The objective of foundation of ICRU was to make the assessments of radiation and their safe and effective use. The objective, I'll repeat, the assessment of radiation means, like we all know, the radiation can be very good or beneficial for us, and on the other hand, it can be very disastrous, like nuclear wars or used as a weapon by any country. So the purpose of formation of ICRU was that no country or no body uses the radiation for wrong purpose. In order to access, it gives some recommendations about the definitions of concepts, units, and operations. So it gives us some recommendations, what we have to follow about the definitions of concept, unit, and how we operate those units. Both ICRP and ICRU developed a hierarchy of quantities, namely. So they had a timely series of quantities, which are usually known as primary limiting dose quantities, which we use for radiation protection, and operational dose quantities. When we work, we require operational dose quantities. So here we see there is another body that is called NCRP, National Congress of Radiation Protection, which acts along with ICRP and ICRU together, which controls the states and it gives the accreditation or certification to the nuclear reactors or hospitals or clinics or industries where the radiation is used.
Ma'am, sorry, I interrupt you, ma'am. Ma'am, somebody else is there actually presenting over here. Your screen is not there actually, ma'am. Sorry. Again, some Verdula Bharati Samla. I don't know. Again, that's a problem. I'm requesting you all, otherwise I have to remove from that. I'm requesting Verdula, can you? Otherwise I have to remove. I'm requesting you. Can you
Vidula Bharti, please turn off your screen.
Ma'am, keep present. No problem. I removed him actually. I removed her,
Okay.
whoever is.
Okay. So I'll start with quantities and units once again. So the first quantity I'm going to discuss about will be very basic one, which we have already started in school, is activity. As we all know, activity is also known as radioactivity, but in short, it is called as activity. It says the number of radioactive disintegrations taking place per unit time, and we measure it as the number of N disintegrations per unit of time. The SI unit, the System International Unit for radioactivity, is becquerel, which was old. The first unit which was given by Curie was Curie, as it was discovered by him. How do we define a becquerel? The becquerel simply is one disintegration per second. One disintegration per second. If we write it in short, it is 1 dps. So what is a Curie? A Curie says the time taken by 1 gram of radium to decay or to disintegrate. So if we correlate becquerel and Curie, 1 Curie is equal to 37 gigabecquerel, or 1 millicurie can be said 37 megabecquerel. And we can also convert it into microcurie and kilobecquerel. By 1 microcurie will be 37 kilobecquerel. Decay constant and half-life. For those who have studied nuclear medicine already know what is the decay constant and what is half-life, but still I'll revise it. Decay constant is the probability that a nucleus decays in a time interval. The decay constant is same for a radionuclide. But different for all the radionuclides. Like for radium, it will be different from gold, from cobalt. But for all the radium, it will be same. It is denoted by lambda. Lambda says disintegrations per unit of time. dp, probability that a nucleus decays in time interval dt. The quantity related to decay constant is half-life. We usually do not hear the word decay constant because we usually use the term half-life. Half-life is the time taken for a radionuclide to decay to half of its original value. It is denoted by T half 0.693 divided by lambda. Lambda is again decay constant. The unit which is given for half-life is seconds, minutes, or hours, because it says the time taken for radionuclide to decay to half. Flux. This is another unit which is not usually discussed. The fluence rate means the rate at which the photons or particles pass through an area per unit of time. This rate at which photons pass through the area is called flux. Flux is represented by phi, means the number of photons per unit area into time. The unit first will be photons doesn't have any unit. So per meter square per second or per centimeter square per second. Energy fluence. It is the amount of energy passing through the unit cross-sectional area. So it will be radiant energy incident upon the area. The unit will be energy joules, area meter square. Kerma. Usually, for diagnostic range, we do not discuss about kerma because it is more correlated in radiotherapy, where we require very high radiation dose. It is sum of initial kinetic energies of all charged particles liberated by a photon in a mass of 1 kilogram of the medium. And kerma is denoted by kinetic energy by weight. DETR is the sum of initial kinetic energies of all charged particles liberated by charged particles in a mass dm. The medium of interaction of the photons must be specified while measuring kerma. Medium of interaction of photons, where it occurs like in solid, liquid, or gas. For example, when interacting with the medium air, it is called air kerma. The unit for kerma is again joules per kilogram because this is energy per kilogram of body weight. The unit which is given in radiology specifically is called gray. Then exposure. Exposure is nothing but which we usually use the term in radiology department. It's the amount of charge of either sign, either positive or negative, produced by ionizing electromagnetic radiation. I did say ionizing electromagnetic radiation. I did not say X-rays. Means we can use the term exposure for gamma radiation, beta radiation, as well as alpha radiation as well. Per mass of air. Exposure is measured in air. So, amount of electrical charge produced or ionization result per kilogram of air. It is denoted by X. We have taken X of exposure. It is number of charge produced per number of mass or per unit of mass. So, it's a unit very simple, charge coulomb and mass kilogram. The special unit which is given in the radiology department, it is again SI unit. It is said 1 Rontgen. Rontgen is the unit for exposure, which is represented by X, capital X. 1 Rontgen is equal to 2.58 multiplied by 10 raised to the power minus 4 coulombs per kilogram. 1 Rontgen is defined as number of ion pairs, either positive or negative, produced by a gamma ray in definite narrow area per cc standard environment, which we call as SGP, means standard temperature and pressure, which produces 1 ESU of electricity. So if we convert 1 Rontgen, which was equal to 2.58 into 10 to the power minus 4 coulomb per kilogram. So 1 coulomb per kilogram should become 3876 Rontgen. After exposure, we heard about the term exposure, which measures the charge in air. But what if we want to measure the charge or the effect of radiation on the human being? We have to have a separate ionizing radiation per unit mass of material at the point of interest. So, if we measure the radiation of a human body, we have to measure the absorbed dose. It says how much of energy is deposited by the radiation per unit mass of material. Here, the unit mass would be in the body at the point of interest. It is denoted by D. Absorbed dose is denoted by D. And it is formulated by the mean energy, means we are going to measure it in a kilogram in a small area, and we have to calculate it at a point of interest. So we have to divide it by the mass. Mean energy imparted to the matter of mass m, where m is the small component of the whole body. SI unit is gray, which is SI unit means special old unit was RAD, which is again the short form of absorbed dose. How? Actually, the full name of absorbed dose was radiation absorbed dose. dose. I'll repeat, the full name of absorbed dose was radiation absorbed dose. Lately, the radiation word was omitted from here, and thus we shortly call it that absorbed dose. But the name of the old unit still remains RAD. 1 gray is equal to 100 rad. And if we correlate the gray to joules per kilogram, it's 1 joule means energy deposited per kilogram of body. So 1 joule per kilogram. And if we correlate rad, we can say 1 rad is equal to 100 ergs per gram. I'll repeat, 1 rad is equal to 100 erg per gram. So, radiation absorbed dose or absorbed dose is the total amount of energy deposited in a matter. It is the product of dose and mass over which the energy is imparted. The unit we have already discussed, gray and rad. Then comes the equivalent dose. Now, what happens? We have studied about the radiation absorbed dose or absorbed dose. But if we compare two different type of radiations, two different types of radiation means X-rays or gamma rays or beta rays or alpha rays, they can be different. Photons of all energies means X-rays of all energies are not as neutron or heavy neutron by simply measuring the absorbed dose. Equivalent dose is decided in order to measure and compare the radiation effect because of different type of radiation. So, equivalent dose is the product of absorbed dose received by the tissue T from the radiation and radiation weighting factor. You simply have to multiply the absorbed dose by radiation weighting factor. So, equivalent dose is denoted by H, H, capital H. H should be dt, that is, D was dose, absorbed dose, multiplied by WR. WR means radiation weighting factor. Radiation weighting factor means it weighs the radiation or damaging power. Formerly, it was also called the quantity factor because it determines the quality of radiation and then helps us calculate the effect of radiation. The man is called the radiobiology. He already what is LET and what is RBE. But I'll still go in short about LET and RBE. LET is linear energy transfer. That means when radiation passes through the body, how much of energy, amount of energy is transferred to the medium, to the body, along the length of the tract. Along the length of the track means per unit length. So LET is denoted by EL, which is energy divided by length, how long the distance was traveled by that radiation. Simply is a measure of how damaging the radiation can be. If the radiation is higher, the amount of energy transferred per unit length will be higher. But here, it is a relation. We do not use the RBE as direct. We can compare two different type of radiations using the RBE. See, dx by dr, absorbed dose of radiation from a standard radiation, which we have already measured, and absorbed dose of radiation type R that causes the same amount of biological damage. Radiation type R can be anything. If the standard radiation is X-ray, it can be alpha, beta, gamma. So it is a comparison. RB is a unit less quantity and is more for high LET radiation. So RBE doesn't have any quantity. The unit for LET again has, I think it was kilo electron volt per micrometer of length. So finally, we talk about the unit of equivalent dose. The unit for equivalent dose is severe as per the System International System. And the old unit was REM, which was in full form Röntgen equivalent min. REM, Röntgen equivalent min. Again, you see the comparison here. 1 severe is equal to 100 REM, meaning the new SI unit is bigger than old unit. REM is defined as the amount of ionizing radiation such that the dose delivered per gram of living tissue per 1 rad has the same effectiveness as delivered by 200 kilovolt potential applied to the cathode tube. So we compare the energy or dose per gram of living tissue per 1 rad. So these are the radiation weighting factors. If we are given the absorbed dose and we know the radiation weighting factors for all the types of radiation, we can simply calculate the equivalent dose. I'll repeat. If we are given the absorbed dose, if we are given the absorbed dose and we want to calculate the equivalent dose, we simply have to multiply the absorbed dose with the weighting factor. Radiation weighting factor is fixed for any type of radiation and all the energies of radiation. So we simply have to multiply the absorbed dose by radiation weighting factor to get the equivalent dose. Finally, effective dose. We have compared in the equivalent dose the types of radiation damage on the body. But what about the different organs? Not all the organs have the same sensitivity towards the radiation. The tissue has different radio sensitivity. You may have heard that we prefer skull PA over skull AP because we know that orbits or the lengths of orbits are much more radiosensitive than the bone. Similarly, there are many other organs like breast and gonads which are much more radiosensitive as compared to the other body tissue. In effective dose, we are simply going to compare the radiation damage caused by any type of radiation to any tissue. So here we are going to use the term tissue weighting factor. The factor is called tissue weighting factor and the effective dose is denoted by E. E is equal to summation of H, that was equivalent dose multiplied by tissue weighting factor. These are the tissue weighting factors given for almost all the organs. If we see here, gonads are very, very highly sensitive to the radiation, 0.20, then colon 0.12, stomach 0.12, breast 0.05, esophagus 0.05, and so on. Oh, I forgot to discuss about the unit of effective dose. The unit given to effective dose is sieverts. Sieverts. Now, the last one is collective effective dose. What is collective effective dose? The thing is, we do not measure the radiation exposure to one person unless and until that person is radiation personal, radiation sharp. When we measure the damage to a group or a population, we use the term collective effective dose. We have to do nothing here. We just have to multiply the radiation dose to the number of people exposed. So it takes account the number of people exposed to a source multiplying by the average dose to the exposed group from the source by number of individuals in the group. The unit which is given to the collective effective dose is same as effective dose, except that because it is collective, we have to use it with person. It is also called man severe. The more the number of men, the more will be multiplied, the more number will be multiplied with the effective dose. So person severe or man severe. So here we see what are the useful radiation quantities and units which we would require or are important. For radioactivity, it is activity or radioactivity in becquerels or curies. For exposure, when we measure it in air, we use coulomb per kilogram or Röntgen, that was capital R. Absorbed dose, when we measure the radiation to the skin, or energy per unit mass of body weight. The absorbed dose unit being gray, or RAD, as I told you, radiation absorbed dose. Then equivalent dose simply multiplies the absorbed dose by radiation weighting factor and the unit becomes severe. Severe. Finally, effective dose. Effective dose again is the equivalent dose which was represented as capital H multiplied by tissue weighting factor. And again, because tissue weighting factor is unitless, it will remain sieverts. So I'll skip these slides and I encourage you all to ask your questions in the chat box.